we're doing another partial fraction decomposition. This one looks really similar to the last one we just did, except it's not going to work out quite as nice. So we have 3x plus 11 over x squared minus 4x plus 6. So what you want to notice is our bottom term, the denominator, is not factorable by your standard method. And the derivative of the top, or sorry, the derivative of the bottom is not equal to some constant multiple of the top, so this isn't just a natural log either. So what we're going to have to do is complete the square in the denominator. So, with the coefficient of our b being 4, x squared minus 4x plus 4 would be a perfect square. We have plus 6, so we can just reduce that to x, or we can expand that to x squared minus 4x plus 4 plus 2. So obviously that's the same thing as what's up there, but x squared minus 4x plus 4 is a perfect square. So what we end up with here is 3x plus 11 over x minus 2 squared plus 2. So at this point, there's a couple of different things that we need to do. So we need to figure out what the derivative of this bottom part would be, and we could then try to get that in the top. So the derivative of this bottom part, since this is just a constant, that doesn't matter. We would get 2 times x minus 2. So what we need to do here is figure out what we need to have in the top in order to have that same thing. So what we're looking for in the bottom, let me put just the derivative of the bottom is 2 times x minus 2. So we need an x minus 2 up here in the top. Well, we could have that pretty easily if we had 3x minus 6, because then the 3 would factor out of the top. So let's think about what we have then and what we can convert. So the best way to do this in this type of problem is split it up into two integrals. So, like I was just saying, since the derivative of the bottom is 2 times x minus 2, we need an x minus 2 in the top so that that would turn into a perfect ln. So this has to have a minus 6 for us to do that. You can't just subtract 6 from the top, though, without also adding it. However, if you want to add 6, we might as well add it over here, because that's the same denominator, so that's not changing anything. If we add 6 here, we could just break that off as another fraction and then add it to that one. So you might as well just add it to this here. So what I just did was basically put a minus 6 plus 6 on the top of that. But I did it in such an order so that it makes sense for this to be a perfect natural log and now this to be an arctangent function. So let's do this. Here, I'll write this one out, but some of you might just see this already. We're saying we want u to be x minus 2. That means du and dx are the same. In other words, we don't have to put anything there. So what we get here is 3 integral of u over u squared plus 2. So that's pretty simple to do in terms of being an ln. We get a natural log if the top is the derivative of the bottom. Well, the derivative of the bottom here is 2u. So if we want to put a 2 here, we have to divide by 2 here. Because if you multiply by 2, you have to divide by 2, because you want to keep it the same. So that means that this whole thing now is just ln of u squared plus 2. We have 3 halves in front. And instead of u, we can put in what we had, x minus 2 squared plus 2. Okay, Okay, if you're confused about that one, I skipped a couple of steps of substitution here, but it's just a substitution problem from there. This one, on the other hand, we have, well, ln plus 6 is 17, which I can put in front. We have 1 over x minus 2 squared, excuse me, plus 2. So this is an arctangent problem, and you can recognize that by a couple of different ways. We have something squared plus a number on the denominator, and we have nothing in the numerator. That should immediately tell you that this is an arctangent. But remember, you have a couple of rules for the arctangent, because if this number that you're adding is not 1, you have to use the square root of that to divide by everything. That's called the a in that formula that you probably remember. The other thing is, instead of x squared, we have x minus 2 squared. But that doesn't change anything for the same reason that this substitution really doesn't change anything. The derivative of x minus 2 is just 1, so it's not changing anything else about the problem. So what we get here is an arctan, but what we need to be careful about is it's the arctan of x minus 2, because that's the variable, but we have to divide by the square root of 2, because our number that we're adding there is not just 1. There's a 17 in front of that, and that also has to be divided by that square root of 2. So remember that anytime you have an arctan problem and the number you're adding is not 1, the square root of that has to go under what's in the arctan and what's in front of the arctan. So we get 3 halves ln of x minus 2 squared plus 2 plus 17 over square root of 2 arctan of x minus 2 over square root of 2 plus c. And that's our final result here. So this ended up actually not being a partial fractions problem, even though it looked like it at the beginning. So if you have to complete the square, chances are your answer is going to end up with an ln part and an arctan part.